So far, we've seen how we can use piping to store our cracking progress, and we've seen how to use it to generate a word list and pipe it to aircrack-ng on the fly without storing that word list on disk, which allow us to use huge word lists that we don't even have enough space to store. Ultimately, and what I want to show you in this lecture, is how to combine both of these ideas so that we can use huge word lists without storing them on our disk, and at the same time be able to pause and resume whenever we want so we can store our cracking progress. Again, we're going to be using Python this time, and we're going to be combining everything that we learned so far. So the idea is going to be like this. First, we're going to be using Crunch to create our word list. We're going to pass the word list to John, which will read the word list made by Crunch, and it'll allow us to save and restore our progress. So the only reason we're using John is to be able to store the location where we reached in the word list so that when we start the cracking again, we don't start from the start of the word list, we start from where we left. Then, since John knows where we stopped, we're going to start from there, and it's going to modify our word list. So it's going to take out, for example, the first 10,000 words that we tried already. So we're going to have a modified word list, and that's the one that we're going to be piping or passing to aircrack-ng, which will do the cracking, which will do all of the heavy work if you want to think of it that way. So right now we're going to be combining what we learned so far, and let me show you how to do it. It'll become much more clear when we do it. So I have my terminal here, and like we said, the first thing that we want to do is to generate our word list. And again, you can use any crunch command you want, but right now I'm going to use the command that I used in my previous lecture, which is just crunch 88. Like I said before, this will generate word list of length 8, and it'll use combinations of all of the small alphabet characters. So it's A, B, C, D up to Z, all small. Now this is a very big word list, and if you want to use something custom, something different, then you can put the command here any way you want, as I showed you before in the crunch lecture. But for now, we're just going to keep it at this because this is a big enough word list. Then we're going to use the pipe character to pipe the result of this command to John, because we said we're going to use John to allow us to store and resume our progress. So our command is going to be John. And if you remember in the lecture where we did the pause and resume, we passed a word list, an already made word list, to John. Now in this case, Crunch is making the word list for us, and it's being passed to John. So it's being passed to John as the standard input. So we're going to tell John to read the word list from the standard input. And we can do that using the std_in argument. Then we're going to give it a session name. So this is the name of our cracking session. So I'm going to do session, and let's call it session 1. Then, just like we did before in the John lecture, we want to pass all of this to aircrack-ng. So we want it to display the word list that it's going to modify on the standard output. And again, we do this using the std_out argument. Now we're generating our word list using Crunch. We're passing the result to John. And we're telling John that I want you to read this from the standard input and store all of the session in a session called session 1 and display the result on screen on std_out, so on the standard output. Then the last thing that we're going to do is pass this to aircrack-ng. So our command is going to be aircrack-ng, exactly the same command that we've been using in the previous lectures, -b to give it the BSS ID of my target. Then we're going to do -w, and we usually give the word list after this, but as we've seen in previous lectures, when we're piping the word list, we give it a dash to tell it to read the word list from the standard input. Then we give it the file that contains the handshake, and in my case, it's called handshake-01.cap. So let me go through the command one more time, just so that everything is clear. So the first command is crunch 88, and as we seen before, this command will display the word list on screen. So it's displaying the word list on the standard input. We put the pipe character to pipe the standard input into John. And then we tell John to read its word list from the standard input. Before we used to give John a word list, but right now I'm telling John to read your word list from the standard input. I want you to store this in a session called session 1. And I want you to display that on the standard output. So that's again displaying it on screen. Then we're piping this standard output as an input for aircrack-ng. We're given the BSS ID of my target network, and then we're telling aircrack-ng to read the word list from the standard input by giving it the dash in here. And then we're giving it the handshake file that contains my handshake. Now I'm going to hit enter. And as you can see now, aircrack-ng starts the cracking process. It's reading the word list that's being generated by Crunch on the fly, and that word list is going to contain characters from A to Z, all small characters. And as you can see now, aircrack-ng is going through these word by word right now. Now, if we do Control C, at the same time, our progress is going to be saved. So I'm going to do Control C. And let's see how we can restore our session and start from where we left in here. So I'm going to clear this. So again, the first thing that we're going to do is generate our word list, and it's going to be crunch 88. Then we're going to pipe this to John. And we're going to tell John this time. Last time we told it to read the word list from the standard input and then display it on the standard output. Right now we don't need to do that. All we have to do is just tell John to restore and give it the name of my session. And the name of my session was session 1. Then this will display everything on screen. So it's going to display the modified word list from this on screen, and then I'd want to pass this to aircrack-ng, and again my aircrack-ng is going to be very similar to the aircrack-ng that I've been using. So it's going to be aircrack-ng. We're going to give it the BSS ID of my target network. We're going to give it the word list, and again we're going to use the dash to tell aircrack-ng to read the word list from the standard input. So I'm not giving it an actual file. And then we're going to give it the name of the file that contains the handshake, which is handshake01.cap. Now, let me explain to you what's going to happen. So first of all, we're doing crunch 88 to generate the word list. And with this, because we wanted to keep generating the word list, because for example, let's say we reached line 10,000, we wanted to start from line 10,000. So we still have to use crunch to start from there. And then we're using John to restore our session because Crunch doesn't know where we were. So using John, we're going to be starting from the line where we left off. John is going to display that on screen, and we're piping that output. So the screen is the standard output, and we're piping that output to the standard input of aircrack-ng. And aircrack-ng is catching that because we're doing -w dash, which tells aircrack-ng to read its word list from the standard input, which is being piped by John. Then we're giving it the name of the file that contains the handshake. Now if I hit enter, I should start cracking from AAAAI instead of starting from AAAA. So I'm going to hit enter. And as you can see, we are at AAAAJ, which basically J comes after I, which basically means that we restored our session. And using this method now, we can first of all restore our session so we can stop and resume whenever we have the time. We can use huge word lists because we're not storing the word list on disk. We're generating the word list on the fly and then piping it to aircrack-ng. So with this method, we can use huge word lists and we can store our progress without using too much space on our computer. Our next video is sniffing captive portal login information. Using ARP spoofing, thank you.